Good evening, everyone. My name is Pranav, and I am studying in Institute of Aeronautical Engineering, which is also known as IARE in BTech first year, second semester, CSE AML branch. Today, I am going to talk about one of the most interesting topics, which is homogeneous equations in computer science. So, coming to the introduction, differential equations are mathematical equations that involve functions and their derivatives. They are used to describe how one quantity changes with respect to another. Among different types of differential equations, homogeneous equation forms an important category. These equations have special properties that make them easier to solve using substitution methods. In computer science, homogeneous equations helps analyze the behavior of algorithms, recursive processes, and dynamic systems. So, what is actually homogeneous differential equation? It is a differential equation is said to be homogeneous if it can be expressed in the form of dy by dx equal to f of y by x. This means the function on the right side depends on the ratio y by x and not on the variables separately. Because of this property, homogeneous equations can be simplified using substitution techniques. This makes them easier to analyze the solve compared to many other differential equations. So, coming to the mathematical form of homogeneous equations, another common form of homogeneous differential equations is m of x comma y of dx plus n of x comma y into dy equal to 0. So, here where m of x comma y and n of x comma y are homogeneous functions of the same degree. A function is considered homogeneous when each term in the function has the same total power of variables. This property allows the equation to be simplified by dividing through by an appropriate power of the variables. Because of this structure, homogeneous equations are commonly studied in calculus and applied mathematics. So coming to the homogeneous function, a function f of x comma y is called homogeneous of degree n if it satisfies this condition, which is f of tx comma ty equal to t power n f of x comma y, where t is the constant. This means that when both variables are multiplied by the same constant factor, the value of the function changes proportionally according to the degree of the function. Homogeneous functions appear frequently in physics, in engineering, and computer science because they present systems where variables scale proportionally. Method of the solving homogeneous equations is homogeneous differential equations are generally solved using a substitution method that simplifies the equation. The key idea is to convert the equation into the form where the variables can be separated and integrated. The most commonly used substitution is v equal to y by x. Using this substitution helps express the relationship between the variables in terms of a single new variable. This transformation simplifies the structures of equation and makes it easier to work with. After applying this substitution, the equation can often be converted into a separate differential equation, which allows us to integrate both sides and obtain the general solution. So coming to the transformation process of this, after substituting y equal to y by x, the variable y can be written as y equal to vx. To proceed with solving the equation, we differentiate y equal to vx with respect to x. This gives dy by dx equal to v plus x of dv by dx. This expression is then substituted back into the original differential equation. By doing this, the equation becomes simpler and can be rearranged into a form where variables v and x can be separated. Once the variables are separated, integration can be applied to find the general solution of the equation. So coming to the example of this homogeneous equation, consider a differential equation dy by dx equal to x plus y by x. So this equation can be written as dy by dx equal to 1 plus y by x. Since the equation depends on the ratio y by x, it satisfies the condition of a homogeneous differential equation. By applying the substitution v equal to y by x, the equation can be transformed into a simpler equation involving V and X, which can be solved using a standard integration methods. The importance of this method in computer science is homogeneous differential equations are useful in several areas of computer science and computational mathematics. They help represent systems where variables change in a proportional manner, which is common in computational models and simulations. Such equations are used in analyzing system behavior, predicting performance trends, and understanding relationships between computational parameters. They are particularly useful in modeling dynamic systems where variables evolve continuously over time. The applications in this algorithm analysis is in computer science, algorithms are often analyzed to understand how their performance changes with increasing input size. Differential equations can be used to approximate the behavior of algorithms, especially in the continuous models of recursive process. Homogeneous equation helps describe relationship between variables such as input size, processing time, and computational complexity. By studying these mathematical models, developers and researchers can optimize algorithms and improve computational efficiency. So these applications in are also used in machine learning. Machine learning algorithms often rely on mathematical models to describe how parameters change during the learning process. Differential equations are sometimes used to model the dynamic behavior of optimization algorithms. For example, gradient-based learning methods adjust parameters gradually in order to minimize error functions. The change in these parameters over time can be described using differential equations. Homogeneous equations help represent situations where the relationships between variables remain proportional during the learning process. This allows researchers to better understand how learning algorithms evolve and coverage toward optimal solutions. The advantages of homogeneous equations are homogeneous differential equations provide several advantages in mathematical analysis and computational modeling. One important advantage is that they can often be simplified using substitution techniques such as v equal to y by x, which transforms the equation into separate form. This makes the equation easier to solve compared to the more complicated differential equations. Another advantage is that these equations are useful for modeling system where variables change proportionally with respect to each other. Because of these characteristics, homogeneous equations are widely applied in many scientific, engineering, and computational problems. The limitations of the homogeneous equations are, although the homogeneous equations are useful in many situations, they cannot be represent every type of differential equation that appears in real world problems. Some systems involve non-linear relationships or additional variables that cannot be simplified into homogeneous form. In such cases, other type of differential equations or numerical approximation methods must be used to analyze the system. Understanding these limitations help researchers and engineers choose the most appropriate mathematical model for solving a particular problem. So, the role in mathematical modeling is homogeneous equations play an important role in this mathematical modeling of dynamic systems. They are particularly useful in describing situations where variables maintain proportional relationship during changes in a system. Such models are commonly used in scientific simulations, engineering calculations, and computational algorithms or programs. By applying homogeneous equations, complex systems can often be simplified into forms that are easier to analyze and solve mathematically. So, coming to the future applications in computer science, with the rapid advancement of computing technologies, mathematical modeling is becoming increasingly important in computer science. Homogeneous differential equations may be used in advanced simulations, artificial intelligence systems, and optimization techniques. They can help researchers understand how complex computational systems evolve and how different variables interact with each other. Their ability to simplify mathematical relationships makes them valuable tools for solving challenging computational problems in the future. Coming to the conclusion, homogeneous differential equations are important topic in calculus and applied mathematics. They provide a structured method for solving certain types of differential equations by transforming them into simpler separable equations using substitution techniques. In computer science, these equations are useful for modeling dynamic systems, analyzing algorithms, and understanding relationships between computational variables. Studying homogeneous equations helps develop how strong mathematical foundations that support advanced research and problem solving in computational science. Thank you.